If you are viewing this video instead of a standard Google Meet, that is because we have lost internet because of the weather. And instead of our classic meeting, we weren't able to actually have that. So instead, we have a recording that is going to simulate what we would have done in class. It'll be like you were there the whole time. You may have noticed that I have been uploading some things to Google Classroom since Monday, and you can view those in the classwork. We are going to be putting on hold the science safety exam until we come back. We'll set aside the 2 days once we're back. The first day back, we will have a safety review day where we review over your safety material that's for your exam, and then the following day we'll have your safety exam. I'm not going to have you take one while you're at home. It's not very fair to those that may not be able to virtually take the exam. So we will just wait till everyone is on the same page and do it then. So while we wait to be back in person for school, we're going to switch gears and start to our first actual chapter for the year. And that for your class is plate tectonics. And that's going to lead us into our next chapter, which is history of Earth. So I uploaded 4 things in your classroom. The first 3 are materials, and the last one is an assignment. You can tell the difference between them because materials have the clipboard with the bookmark, or the book with the bookmark rather, and then the assignments are a clipboard. You can also tell by how the date is posted. Materials have a posted date, while assignments have a due date. The thing we're going to be covering today is your Chapter 1 introduction reading, where we're going to introduce you into the chapter. We're going to look at what some concepts we're going to be covering, and then we're also going to be looking at your chapter projects. Tomorrow we'll be looking at the Chapter 1 presentation, which is a Prezi, just like what we used last year. Click on the link, it'll take you right to the Prezi. And then the Chapter 1 Section 1 reading is what you're going to be reading on your own time. What we talk about in the presentation tomorrow coincides with the reading, but I suggest to you to do the reading so that you can do the Section 1 questions. Now, I've had some people turn in that work already, and I'll be looking through those posts, and I may be sending those back to you, especially if perhaps you've missed something, or maybe you didn't answer a question fully, and so you wouldn't receive full credit. I like how you guys really jumped on the ball with that. As soon as I posted the assignment, everyone was looking at it and starting it. That, to me, was really exciting. But as we progress through this section, if you notice that you may have answered some things not necessarily incorrectly, but maybe you didn't fully answer it, by all means, please resubmit that. If you get an assignment sent back to you, please look for the comments. I will tell you what you need to do for that, and then you need to send it back through. So my suggestion to you, if you have not already turned this in, is to wait until we get done with the introduction reading and the Section 1 presentation so that you get a general understanding, and then read this part and then answer the questions. So we're going to go ahead and start into this. I'm going to click on the material. You can either view material or you can just go ahead and click on it. I typically just click on what's already visible, and then you'll be able to read this. If I ever upload a document and it will not open for you or shows as a blocked document or locked document, please comment on that material or assignment to let me know. I can't tell on my end, but sometimes the Google Drive will lock it out of anybody viewing it except for me, and it doesn't tell me. It's supposed to only be for our school account emails, but sometimes it blocks it for everybody. So just comment on the assignment once and just let me know that, hey, it's not working, and then I can update that, fix it. So with our introductory reading for this chapter, we're going to be looking at volcanoes and how we can actually monitor and study them with some pretty awesome technology. If we were in a normal Google Meets, we would take turns reading, but because we're not in a usual meet, we'll be reading this and you can follow along. And I'll also explain some concepts as we go through. And at the end, we'll talk about your chapter projects. Studying volcanoes with satellites. New ways of viewing Earth are giving scientists powerful tools for learning about and predicting volcanic eruptions. Scientists that study volcanoes and predict eruptions are known as volcanologists, which I think is pretty cool. It's sort of like a Star Trek reference. Deadly eruptions. On the island of Montserrat in the West Indies, small eruptions of the Soufriere Hills volcano began in 1995. These early warnings gave people time to move away, several months before the first of the large explosions. So this is a satellite image of that eruption. People living in the towns near Nevado del Ruiz volcano in Colombia were not so fortunate. On a night in November 1985, a storm hid the snow-covered volcano. No one could see the start of an eruption. Huge amounts of snow and ice melted and mixed with volcanic ash to form mud flows that killed 25,000 people. The flow that buried much of the town of Armerio traveled 74 kilometers in just 2.5 hours. Throughout history, volcanic eruptions have caused some of the world's worst disasters. Warnings might have saved hundreds of thousands of lives, but in most cases, people had no idea that soon a rain of hot rock, toxic gases, or other deadly effects of an erupting volcano would soon engulf their area. By the time people realized the volcano was erupting, it was too late to get away. Today, scientists monitor volcanoes around the world to help avoid such tragedies. Predicting volcanic eruptions. Scientists who study volcanoes paid close attention when an instrument on a weather satellite unexpectedly saw hot ground in 1996. The instrument's usual function is to measure cloud temperatures, but this time detected an area of increased heat on Alaska's Pavlov volcano. The scientists predicted the volcano would soon erupt. 3 days later, it did. This eruption was the first to be predicted with information from space. Now, computers check satellite data as they receive the data. An unusual hot area trigger an automatic email alert to scientists. So in this image, you can see this darker area here. That shows a hotter temperature, this darker blue. And this is actually the Pavlov volcano itself, the satellite image. In 1999, NASA launched the Terra Satellite as part of a program to study Earth's surface and atmosphere. Among Terra's instruments is one that detects heat given off by the planet's surface. When scientists observed an unusual increase in surface temperature, they determined whether magma is rising underground. In some cases, unusual heat has been the first sign that a volcano is building towards an eruption. After an eruption, satellites are also used to monitor eruptions as they happen. Lava flows show up clearly, as you can see in the Terra image below. In addition, satellites are used to track the locations of volcanic ash and gas clouds. Airplanes flying into this material can be severely damaged, so pilots need to know where it is. Organic material in the air can be difficult to see or to distinguish normal clouds, especially at night. Satellites are particularly helpful in identifying and tracking eruptions in remote areas where there are few or no observers. Explosive neighbors. Satellites such as Terra are among the tools scientists use to monitor restless volcanoes near urban areas. Mount Rainier, a volcano in Washington, looms through the large cities of Seattle, and Tacoma. In the past, heat from the eruptions has melted large amounts of ice and snow at the top of the volcano, creating mud flows that destroyed everything in their path. Another extremely dangerous volcano is Mount Vesuvius near Naples, Italy. Timely warnings before eruptions of such volcanoes can allow authorities to safely evacuate the millions of people who live near them. So through our research and studies and collection of data, we answered questions, but with those answering of questions, we also produce more questions. And that's the way science works. When you ask yourself a question and you look it up, you research it, you perform experiments, and you answer that question. But with that answer, you then get more questions. So science is a building of questions and answers on top of each other. So with these, we have 3 unanswered questions that volcanologists and Earth scientists like to focus on. So even when scientists predict that a volcano will erupt soon, many questions still cannot be answered. So how powerful will the next eruption be? On what day or even during what week will the volcano erupt? And how much magma is rising under the volcano and how fast is it rising? Will it stop? By the end of this chapter, you will need to choose one of these 3 projects and have it completed. If we were in a typical classroom setting, you would be able to either do this solo or with a group of up to 3 people. But because we have some virtual aspect to this chapter, you will need to do this one solo. And none of these projects, I feel like, would be impossible as a solo. So what is it that you can do for these chapter projects? So of these 3, the first one is review movie science, earthquake report, and ashfall fossil exhibit. So what is it that you need to do for each one so that you can pick the best one that you feel you would be able to accomplish before the end of the chapter? So for review movie science, review a movie that features a volcanic eruption to evaluate how accurate the movie's depiction of the volcano is. Visit the U.S. Geological Survey website for a list of movies about volcanoes, such as Dante's Peak. You'll then evaluate one movie and prepare a report on it for a radio or TV spot. This should be no more than 1 page. So after you evaluate the movie, you're going to prepare a report that you would record as a video if we're virtual or present in class if we're in person. Earthquake report. Make a map of the volcanic eruptions and earthquakes that occur around the world while you are studying this unit. Write a news report and create a graphic to show the events, locations, and intensities. Present your findings as a special TV report recording for an evening news program. So you'll need to write a news report and create some form of graphic to show those locations, whether it's like a map and you pinpoint the locations with intensities or whatever you want to do for that to show it so that you can record a video and present that in class. And last but not least is the ashfall fossil exhibit. You're going to prepare an exhibit showing how volcanic ash can preserve fossils of the organism it buries. You could begin by researching the Ashfall Fossil Bed State Historical Park in Nebraska or research Pompeii. You're going to create a poster that shows the major steps in the formation of fossils of creatures in volcanic ash and then make models or tracings of some ashfall fossils. With these projects, I really encourage you to be as creative as possible, but don't get lost with the creativity. Make sure you still do the things that you need to do for the project to get that good grade. And then, by all means, be as creative and artistic as you want with them. If you have any questions for these projects, you can ask those questions, especially during our Tuesday, Thursday meets, where you can pop in and ask questions and get help for your work. Next week, once we come back from the Labor Day holiday, we will be going back on a regular virtual schedule. That is, if we are virtual, depending on what that call is going to be. We will not have school on Monday because that's Labor Day, but then we'll have the Tuesday, Thursday class meeting where you pop in and answer questions. You don't need to be there for the whole meeting time. But then Wednesday and Friday we'll have class where you need to tune in if you're able to the virtual meeting itself. And if you do miss the meeting, remember that we do record the meetings and we do post them onto the Cass and Science YouTube channel. And those are through a private link, unless it's like this recording here where there's no students in it at all. So this isn't showing the 3 that I have uploaded from today that are private. They're only linked to the class, and they click on it and they can view it, but you cannot if you're not part of the class. But this one will be uploaded publicly because it's just me in the video, and I don't mind if it's public. So hopefully I'll see you tomorrow. Stay safe, and if I don't see you tomorrow, maybe I'll see you next week if we're back in school. If not, I'll see you in the meeting.